Okay guys, in this video we're going to be looking at how we can switch back and forth between the rectangular form of a coordinate point to the polar form of a coordinate point. And so because we do this so routinely, what I'm going to do before I go into just like drawing a picture and talking about the practical way you do this is to talk about the general way we do it. And so really quickly, let's go ahead and re-sketch what we look at here when we talk about the polar or the rectangular form of a point here. And so the very first way I'm going to start is this. We're going to be given in this video the polar form of a point, so this r theta form. And so that is to say that we're going to know two things. We are going to know exactly how far this is from the origin, and we are going to know this direction angle theta here. Now, up until now, you've seen me doing this. I say, well, you know what, you still want to drop your altitude and actually and make a right triangle out of this. And the reason why is because we're going to relate this back to some right triangle trig here that will allow us to kind of go from polar form, polar, into rectangular form of a point here. So when we talk about the polar form of a point, what we're going to be doing is we're going to be given some r and theta. And what we're going to want to go find are these components x and y that would be the things we would have been given in rectangular form to begin with. And so what I'm going to do is this. I'm going to take for now, take the y part of this off and just say that, look, let's say I know r and I know theta, and what I want to find here is x. How could we find it? I suppose the idea is that this is a right triangle, and because it is a right triangle, we can use SOHCAHTOA. And so that is exactly what we're going to do here. We're basically going to say then, it follows that the cosine of our angle theta would be adjacent over hypotenuse. And this would be how we always relate the x component down here to the hypotenuse. And so that being said, if I know this angle and I know the hypotenuse and what I want to know is x, what we're going to do is we're just going to multiply both sides by r, and what we get is this, something pretty profound. And that is to say that x is always going to be r, which is the distance we are from the pole, times the cosine of the angle that is our direction angle. And so I'm going to put a box around this here. And I'm going to go back now and say, well, now, how could we have solved for the vertical component here if we knew r and theta? And so just like we did with x, we're going to do SOHCAHTOA. But what I'm going to do this time is I'm going to say that we'd have to use a sine ratio. So the sine of theta would have to be y over r. And because we know that the sine of theta is y over r, and because we know theta and we know r and we want to know y, we're going to multiply both sides of this by r. And what we get is this r. Y value is r times the sine of theta. So I'm going to throw a box around this. And so basically what we're going to say is this. If I am in polar form and I want to go to rectangular form, then what we're going to do is this. We're going to say that my point is really, instead of xy, is given as r cosine of theta, which is our x value here, and is given as r sine of theta, which is our y value here. And underneath this I'm going to write, oh, by the way, remember that this is really our x value and our y value here. So knowing that that's the case, we're going to look at number 33 now with a little bit more insight and say, well, then how would this look? Now, here's what this says. We are given this in polar form. So 4 comma 90 degrees means that we're going 4 units away from the origin in a 90-degree direction. So something that's pretty interesting about this is you'll notice that it doesn't even make a triangle. We're just going to have to write 90 degrees here, and we're going to have to write r equals 4. That being said, though, we already know that if the polar form is r theta, or in other words 4 comma 90 degrees, then our rectangular form is r cosine theta, r sine theta. And so if this is our polar, we're going to write our rectangular thusly. We're going to say 4 cosine 90 degrees and 4 sine 90 degrees. Now typically I would just do this on a calculator, but because all of these angles for the most part I see up here are angles that I could find on the unit circle, I'm actually going to evaluate this very explicitly. And so I know that on my unit circle here, all of the points on the outside are my cosine and my sine values. I'm going to look up at 90 degrees and say, well, what is the value of our cosine and sine up here, because of these give us the cosine and the sine. I know that the cosine value is 0 and the sine value is 1. And so in this case we really get 4 times the cosine at 90, which is 0, comma 4 times the sine at 90, which is 1, which in this case leaves us with 0, 0 times anything is 0, comma 4. And so what I want to point out to you here is that, of course, yes, I mean, that makes sense. If you rotate 90 degrees and go 4 units in that direction, you are at 0, comma 4, in the rectangular coordinate plane. But see, this is really more a testament to, well, if you want to know, all you have to do is r cosine theta, r sine theta. So we're going to take a look at one more of these here. Let's say like number 35. And the very first thing that I'm inclined to do is just go ahead and sketch what we have here, but we're going 2 units in a pi thirds radian direction. So knowing that pi thirds is a third of a pi rotation here, that is kind of like this right here. We're given this point right here where we know that this is pi thirds, and we know that r equals 2. And so I'm going to drop down my components here and say, well, this is what we're really looking for, my x component and my y component. But using SOHCAHTOA, remember that if r theta in this case is 2 comma pi thirds, we used SOHCAHTOA. We saw that if I want my polar to go into rectangular, we do r cosine theta, r sine theta. And so I'm going to get r2 cosine pi thirds, cosine theta. And I'm also going to get 2 sine of pi thirds, or r sine theta. So in this case, we're going to say, well, what is the value of cosine of pi thirds? What is the value of sine of pi thirds? And so what I want you to see is that cosine at pi thirds, I don't know, what is our cosine at pi thirds here? It'd be our cosine value up here. And I know that this is over 2 and this is over 2. This starts with a 1 here, and so this is root 3 here. So our cosine value is a half, while our sine value is root 3 over 2. And multiplying these, I suppose, straight across, we get 2 times its reciprocal is 1, and 2 times root 3 over 2, the 2's cancel out here, we get root 3. And so this case, I like drawing the picture a little bit better, just because you see that we made a triangle here, and what I want you to understand is that we found out that this component is 1, this is root 3, and this is 2 here, which, you know, when you think about it, kind of makes sense, because this here is a 30, 60, 90 triangle, where we have the shortest side is 1, the hypotenuse is twice as long, and the long leg is the short side, 1 times the square root of 3. So as you work with more and more of these, just know that if you're given r theta, you want to be really good with knowing then that x is r cosine theta, y is r sine theta. We're going to be doing a lot of time, or spending a lot of time going from r theta into x and y by using that technique. Cheers.